Today we're going to talk about section 11.3, the volumes of pyramids and cones. For the warm-up, it says to draw a cross-section of a pyramid and a cone. I'm not going to have you draw the cross-section, but let's just practice how to draw a pyramid. So let's first talk about the definition of a pyramid. A pyramid has a polygon base, all vertices of the base connect at a point above called the vertex. Okay, so if you look at this figure right here, it has a triangular base, and then you'll notice all of the corners meet up at the top at what we call the vertex. Okay, now a cone is really similar. The only difference is that the base is a circle. Okay, but the edge of the base, notice they're all meeting up at the top. You guys have seen this probably in like an ice cream cone. So for drawing a pyramid, I think the easiest pyramid to draw has a square base or rectangular base. So if I were to draw kind of like a parallelogram, two of the sides like that, and the other two sides I'm going to draw dotted. The reason why I'm drawing them dotted is because they are kind of in the background of the picture. Now, if you try to find the middle of the base, okay, that would be like where your diagonals would intersect. I'm just eyeballing it. And you're going to draw a point straight above there. Okay, I'm going to go kind of high up. That's going to be our vertex. Okay, now all we have to do is connect it to each of these. Now I drew this one as a dotted line just because, again, it's behind the picture. That's in the front. That one's on the side. Okay, so you'll notice you have a nice three-dimensional shape. With a cone, you can kind of copy what we have here, where you have an oval, where half of it is behind. Point, here's our center, point is up above, and connect the sides. Okay, so you'll notice that the height of the pyramid and the height of the cone come from connecting down to that middle point. So there's H, and here's H. Okay. So our formula for the volume of a pyramid and a cone, it's actually the same. It's 1/3 times B, which is the area of the base. Area of the base. 1/3 area of the base times the height. Okay, now the only difference is with the pyramid, you have to calculate the area of the base, or sometimes it's given to you. Here, we calculate the area of a circle using pi r squared, okay? Now, with a triangle, let's just review the area of a triangle, in case it comes up, is 1/2 base times height. So sometimes you'll have to find that area of this shape based off information that's given to you. A rectangle is length times width. Okay, so you might have to find the length and the width of this bottom figure. Those are usually the figures that you're going to be given. Okay, all right, so let's scoot down to our first problem. So Kyle's truck can haul 1.75 tons of corn per load. 1 cubic meter of corn weighs 0.8 tons. How many loads will he have to haul to move this pile? So we have this pile over here. Now notice everything's written in meters. So we've got the lengths here. So this is a cone. It's probably a bunch of corn that's piled up into one pile. So if I've got the distance across, this tells me, and actually this picture isn't the best. I would probably tell you in a problem like this that it's a cone you're looking at. The distance across is kind of like, that's the figure. Okay, we're looking at it from the side, but imagine if you looked at it from the top, it'd be a circle. So it's 4 meters across total, which means our radius is 2. So if I'm looking for our formula, which is the volume equals 1/3 area of the base times the height. We know the area of the base is the area of the circle, pi r squared. Now the radius is 2, so I'm just going to plug that in, times the height of my cone, which is 1.5. Okay, so typing this all into my calculator, we've got 1/3, I put that in parentheses, pi r squared times 1.5. And I end up with 6.283. Okay, now this is the volume of the cone. So we've got meters cubed. Now it's telling us that 1 cubic meter weighs 0.8 tons. So we have this many meters. So I need to multiply by the weight, which is 0.8. Because for each cubic meter, we've got 0.8 of a ton. So if I have this many cubic meters, I have to multiply by 0.8. So I've got 5.026. 5.026 tons. Now, if his truck can haul 1.75 tons of corn, we're going to divide this now by 1.75 to see how many trips we're going to need to take. So notice that we've got about 2.9. Well, I can't make 2.9 trips. I would have to need 3 trips or 3 loads is what they're asking. Okay, so it wasn't just about finding the volume, it was about answering an application problem based off of the volume. A lot of these are going to be like that, okay? Now our next one has a pyramid. Notice that we've got a triangular base. Okay, base doesn't mean it's at the bottom. A base can be at the top. Notice that they're all meeting at a single point. That's what tells us it's a pyramid. So I need to find the area of the base times the height. This capital B, sometimes you see it with a little tail on it, that means the area of the base. Okay, so this is a triangle. We know that the area of the base is 1/2 base times height. So if I'm looking just at the triangular portion, the base is 4, the height is 3. That information is given to us. And the height of the pyramid, that H, is the height of the pyramid. So times 6. Now throwing this into my calculator, we end up with 36 inches cubed. Okay. So how many cubic inches of wax does he need? Well, if this candle, so this is the mold for 1 candle, he needs to make 12 of them. So he would need to multiply this by 12 because we have 12 candles. And that'll tell us how much wax we need to buy. So 432 inches cubed of wax. Again, using what the problem is telling us to answer the final question. All right, let's go ahead and jump to the next page. I'm gonna have you guys give example 3 a try. Go ahead and hit pause and do both parts, A and B. All right, so the nice thing about both of these is that most of the information was already given to you. The only thing with the cone is that you had to use the diameter to find the radius so that we could then use our pi r squared formula. With the pyramid, they gave us the base area. That's the area of the base. That's part of the formula. So there was very little else work that we needed to do. Okay. Now in example 4, it says Samantha's 1.8 meters tall. She wants to be able to stand inside her new tent. should she buy it? Now, the tent is 3.4 cubic meters. That's volume right there, okay? So the square floor has a perimeter of 8.4. Well, what does that look like? If I divide 8.4, divide it by 4 sides, we get 2.1 on each side. Okay, now we know that our volume formula is the area of the base times the height. Now in this case, I know the volume is 3.4, so I'm gonna plug in that information. The area of the base is just length times width, and the height of the tent, that H, I don't really know what that is yet, and that's what we're looking for. The height of the tent, if Samantha is less than the height of the tent, then she'll be able to stand inside of it. But we don't know what the height of the tent currently is, okay? So let's multiply 2.1 times itself. Okay. So if I were to solve for H, we get a height of 0.77 meters. Okay. Now, if the tent has a height of 0.77 meters, but she's 1.8 meters tall, there's no way that she's going to be able to stand inside that tent. Okay. All right, let's take a look at example 5. So a rectangular pyramid has a base that is 3 times as long as it is wide. So I'm going to go ahead and draw that rectangular base pyramid. I'm going to kind of draw it the same way I showed you guys up in the beginning. So it says, let's see, there's our height. Something like that. Okay. So it tells us that the base length is 3 times bigger than the width. So if this is the width, the length is 3W. It's 3 times as big. Now the height is 3 feet. I know that exactly. That was given here. The volume is 75. So again, going back to that formula, area of the base times the height. Oh, I just realized we made a mistake in the previous problem as well. I forgot to put the 1/3 here. Some of you guys might have wondered about that. 1/3. All right, so then that's gonna change some stuff over in this problem. All right, so let's throw the 1/3 in. Good that we caught that mistake. All right, so I've got, I'm gonna go back up to this step over here. 1/3, 2.1 times 2.1. I have 1.47 H. Now we can get H by itself. Let's see what happens. 3.4 divided by 1.47. 2.31. So if the tent is 2.31 meters tall, then in that case, yes, she will be able to stand inside. Totally changed our answer. All right, glad we caught that. Okay, so again, our volume for this pyramid is now 1/3. Area of the base times the height. Okay, so I know that the volume is 75. Okay, 1/3. The area of the base is 3W times W, length times width. And the height is 3. Okay, so now if I were to multiply, let's simplify this a little. 1/3 times 3, that goes away. So I'm left with 75 equals 3W squared. Okay. Trying to get our W by itself, we have 25 equals W squared. That tells us the width has to be 5. Now, if our width is 5, then 3 times the width is going to be 15. Now, they're asking us, what is the perimeter of the base? Well, if we add up all of the sides of the base, the perimeter ends up being 40, what are our units here? 40 feet. Okay. All right, jumping to our next example. The difference with this example here is you'll notice that we're not given the height of the cone. A height will always go down to the center and then down to the point where it all meets. So here, you'll notice that we're given this slanted height. Now, if you look at our picture, this actually creates a right triangle. Notice that my radius is 5, okay, and the hypotenuse is 15. I can find the height using Pythagorean theorem. So I'm going to do 5 squared plus h squared equals 15 squared. Okay, so I have h squared equals 200, the square root of 200. The height for the big one is going to be 14.1. Okay, now the height for our small cone, 3.5 is our radius. Height, 3.5 squared plus h squared equals 12 squared. Square root. Okay, so we have 11.5. Now, if we're looking to see which is the better deal, I'm going to find the volume of each of these, okay? So the volume for this large one, 1/3 pi r squared times our height. Volume for our small cone, 1/3 pi r squared times our height. Okay, so plugging these both into our calculator, we get a volume of the large smoothie is 369.14. Okay, here we have volume of the small is 147.52. Okay, now in order for us to figure out which is the better deal, we know that the large costs $5.89. So if I were to take $5.89 and divide it by the volume, we would find the price per cubic centimeter. Okay, so let's do 5.89 divided by 369.14. I'm going to get a tiny number, but we've got, that means 0.0159 per centimeter cubed, okay? Here, we're going to divide the cost by 147. We're going to divide by the volume, 3.49 divided by that volume, and we get 0.0237 per centimeters cubed. So if we're looking to see which is the better deal, the large definitely costs less for the same amount of smoothie, Okay, now they're giving you more smoothie and obviously they're charging you more, but each individual cubic centimeter is going to cost less. Okay, so we're gonna go with the large in this case. Okay, most of the time for a problem like this, I probably would just have you find the volume or have it a little more straightforward. Okay, all right, so if you guys flip to the last page, I'm not going to work through these problems with you. You guys will try them on your own, but I will post the solutions. I do want to give you some tips though. For example number 7, I'm going to say draw diagrams. It's just going to be a little bit easier. Okay, cones are actually pretty straightforward. They're a little easier to draw than pyramids anyway. So, all right, number 8, we call this a composite figure because it has 1, 2, 3 different types of figures. So this has a, it's kind of hard to see. There we go. This is a pyramid up on top. Okay, the base is a square. Okay, this one's going to be kind of hard to see just because the picture's not very good, but give it a try, see if you guys can get it. This one here is a prism. We saw those in a previous section. And notice each of the 4 legs are cylinders. 4 cylinders. Okay, so see if you guys can find the total volume here. And actually, instead of the concrete mix, don't worry about that. Just figure out the total, find the total volume. That'll be a little bit easier. Okay, now this last one says that we have a cone-shaped hole drilled in a prism. That means we are not going to include, don't include the volume of the cone. That means you're going to be subtracting it from the volume of the prism. So this, we have a triangular prism here, okay? So you guys can try to find that volume, okay? All right, so that's all I have for you guys today. Go ahead and copy the rest of the notes and try these problems, and homework is already posted. All right, guys, have a great day.